So Salesforce is generally known as a CRM product. We're really known for cloud-based business software, so controlling your accounts and your contacts and your opportunities and your leads and so forth right from your browser. And so when we talk to developer communities, I frequently get questions like, you have developers, and yes, we have a few, million of them, and we do have a platform. And I even get questions at some conferences like why are you here? And it's I get it, because why is the Outlook guy here at a big data conference? Like what's the connecting point here? And I actually got exactly that question at an industrial IoT conference not too long ago. And my response was, let's talk about a fridge. Okay, so my dad is retired. And as a retiree, he gets easily bored, and he likes to purchase new toys and things like that. And he really wanted a new fridge. And he wanted a new fridge that had a front-loading ice maker. It was a really big deal to him. He'd never had one. My dad's life really revolves around like Sudoku and drinking lemonade and smoking cigars and drinking whiskey, and two of those things involve ice. So a front-loading ice maker was like, that's a feature he really wanted. So he orders a fridge, and the fridge gets delivered. And the fridge gets installed, and the delivery guys leave, and he goes to use his new front-loading ice maker, and the front-loading ice maker doesn't work, doesn't produce any ice. So he calls the delivery guys, and the delivery guys are like, well, that's not our job. We just delivered it. You signed the papers. We're done. You should call the store. And then he's like, well, he calls the store, and the store's like, well, that's not our job. You should call the manufacturer about your warranty. He calls the manufacturer, and the manufacturer tells him to call the store, and so on and so forth. And basically 3 hours later, my dad still does not have a working fridge, nor does he have any idea of how it's going to get fixed. So once again, my dad also sort of having the inner geek within him, and he's kind of an engineer and had a lot of time on his hands. What he did, of course, was start taking the fridge apart right there in my stepmother's kitchen. And so he's taking the whole thing apart, and sure enough, he finds a tube from one section of the fridge that was supposed to go up to the front-loading ice maker, and that tube was incorrectly manufactured, and it was sealed at one point, and so it wasn't getting pressure. And my dad, being my dad, of course, cut that tube into 3 parts and bore through the section of the tube, and then duct taped the tube back together and put the whole fridge back in place. And I think his exact words when I was talking to him about this was, well, it's working better. I didn't ask, is it working as intended? He's like, is it making ice? Well, it's making ice better. So he had improved it, and eventually, the store was supposed to have, a third-party contract, and they didn't know about it, and it all got sorted out, and weeks later, he finally got the service appointment that he wants. But this is an anecdote because this is not the day one experience that people want to have with their appliances. And when we start looking, and so I'm at an industrial IoT conference, and I'm talking about this, and as I start getting to that point of failure, they kind of know where I'm going with this. Because when we look at the consumer side of what is smart, this here picture is actually a smart fridge. This is labeled as a smart fridge from LG. It has 2 main features which makes it smart. One is a set of cameras that are pointed inside the fridge. So if you need to check whether or not you have to buy milk, for instance, and for some reason you cannot walk to the kitchen and open the fridge to see if there's milk inside, you can apparently load up an app and check to see if there's milk in your fridge. Now, I don't know what fridge they think that will work on. Personally, mine needs robotic arms to move stuff away. If I need to know if I need to buy eggs, you have to remove the 3 layers of takeout food that's in my fridge before you can figure that out. But apparently, if you really need to see inside your fridge, you can with the smart fridge. The other feature it has is this Windows 10 style tablet that's shoved into the front door of it, which apparently does calendar and notes, and you can check your email. And I kind of get this a little bit because fridges are this cornerstone of our daily lives, right? Somebody's going to take a Post-it note and write, pick up Jimmy at 5 p.m., and they're going to put the Post-it note on the fridge, and that reminds Dad to go pick up little Jimmy at 5 p.m., And I guarantee you that some household out there that has this fridge has taken a Post-it note and written, pick up Jimmy on 5 p.m. and put it right in front of that tablet screen, right? So I get the functionality, but when it comes to improving our lives and having this kind of touchstone experience with IoT, I'm not really sure that's the direction smart really needs to go to. And what would be better is if it had something like the device that we see here. And I forget the specific product name, but this is basically a water detector. Detects depth and viscosity and pressure, basically detects the existence and quality of water. And industrial IoT uses this all over the place. They put this on pipes and pipelines so that they know that from point A to point B, that water is where it's supposed to be and it's where it's supposed to go. Now, I don't want to trivialize this. I'm not trying to say that LG could just pick up a couple of these and slap them into the fridge and be done with it. I'm basically proposing taking about 100 miles of pipeline and condensing it down to a phone call. Sorry about that. In condensing it down to a 10-foot appliance, right? So it's not necessarily simple, but the technology is definitely there. And if that technology is there, the appliance gets delivered. My dad has his experience. See, everybody's doing it. My dad gets connected back to some kind of cloud service. So now there's a relationship between my father, the fridge, and the service company that's supposed to help him out. And the first thing the appliance does is it runs a diagnostic. And it says, is everything working okay? And if everything's not working okay, then it determines what's not working okay, creates a case up in the cloud, contacts the right person, and then that person calls my dad. And so now day one experience is my dad realizes that his front-loading ice maker doesn't work, and somebody calls him. And they're like, Mr. Birk, we're very sorry. This is not the day one experience that we want you to have. Your fridge appears to be malfunctioning. When can we send somebody out to do a service appointment for you? And I can't guarantee you with absolution that that is in the near future to you, but I will tell you the first company to do that will make bank on it. Because if you can give your consumer the best, worst first day with your appliance, you are definitely going to get them back as a return customer. And if, for instance, that scenario where we're taking that 100 feet of pipe or 100 miles of pipeline and converting it down is not something in the near future, another way we could go about this would be to do what I like to call the car talk method. Does anybody listen to car talk? NPR, right? So the car talk is these guys click and clack, people will call them up and they'll be like, my car's not functioning correctly. And what they will ask the person on the radio call to do is, well, what does your car sound like? I'm not kidding here. And the person will actually do these really clumsy, like it sounds like clunk, clunk, bum, bum, pow. And click and clack are like, oh, that's your air intake valve. Like they just know right away, like that's the sound of an engine that's malfunctioning like that. In theory, a mobile app could do that as well. Now instead of all of those sensors we replace with a mobile app, we do the exact same flow, we get the same experience. Now, if you think that sounds too pie in the sky, note that LG is actually already doing that. LG has an application, it's called Smart Diagnosis, works with some of their dishwashers and laundry machines. I don't think it works with their fridges yet. However, if you start poking around on this, the reviews for this application are not terribly kind. So it's an interesting idea. It's an interesting stopgap. I don't know how great it is going to be for that best, worst day one experience that you want to have with your consumer. For that, we're probably going to have to start actually wiring things up. So what I want to do is start walking through kind of a more live demonstration of how this kind of thing could occur from an IoT point of view. And before we really get into that, I want to kind of break down where, at least from my perspective, where IoT demonstrations have kind of grown over the years. And it actually, for me, anybody here ever watched Sports Night? Sports Night was an early Aaron Sorkin comedy. It only lasted 2 seasons. It was canceled very, very early on. I believe you can still find it on Hulu. I highly recommend it. It's actually pretty darn hilarious and has some great writing to it. And it was in the late 90s. And there's this episode of Sports Night where they think that the company is in trouble. And so in order to figure out if they need to do something because the company is in trouble, they basically set up the modern, or what was modern at the time, equivalent of a Google News alert, right? So they have a news alert and they're waiting for something to occur. And the ongoing joke during that episode was this line. Jeremy says there will be bells and a siren, then we'll know we're in trouble. And the humor is that the concept that something from the internet could call off bells and a siren is so bizarrely black magic that the fact that the characters believe that this is possible makes them look like country bumpkins. And it would be 1999 that the British entrepreneur Kevin Ashton would actually coin the phrase Internet of Things. And so 1 year later, we're kind of off to the races when it comes to this concept of having a mesh of sensors, having them connected up to the internet, and then having some kind of delivery system back to the humans so that they can actually do something about it. Now, there were a lot of different demos. I'm not saying that this next slide was the apex of sophistication when it came to doing Internet of Things demos. However, my entry into demoing IoT to enterprise clients was in 2013 when a friend and colleague of mine, Reed Carlberg, got the IoT Zone up and running back at Dreamforce, our annual conference. And at that time, it was very maker, right? Like it was a lot of Raspberry Pis and a lot of Arduinos and things like that. So the first ever enterprise IoT demo that I ever did was a Makey keyboard. So Makey keyboard. A Makey keyboard basically takes the same electronic fundamentals as a potato clock. All right. So I believe it's a lime. It was either a lime or an avocado on the side there. That's the negative ground, and then each of the bananas have plants in them, or cords into them. Bananas have high potassium value. So they do a good high electronic charge, a good positive charge. So when you press the banana, it changes that charge slightly. And then that little white thing, that's the Makey breadboard. And it detects that change. So if we converted it to modern IoT, right, this is just getting electronic fluctuations from something off the real world. At this point, just happens to be a banana. So you press different bananas, it goes through the Makey, converts it to a sound, and you have a banana keyboard. And note, this has zero business value, right? There's no connection. There was no other step to this. This was the demo. And Dreamforce is hardcore salespeople, business people, CTOs, CIOs, and they loved this. This was amazing to them because it's the first time they're really seeing do some changes in the real world, have a computer really respond to them. So then my next demo wasn't much better, to be honest, but I felt like I had to do something that might at least possibly have something downstream from what we actually do as a platform. And this is basic Arduino 101 stuff. It's a Python script running off of the Arduino itself, hooked up to a breadboard. Breadboard is connected to the LED light, and the script changes a value, and the LED goes from 0 to 1, and it either turns on or turns off. And the concept there was that we could call into our APIs. And by doing that same downstream response, we could have that LED light go on or go off. And once again, this demo killed, even though, once again, zero attachment to the actual business. By 2014, we had gotten much, much better. In 2014, this is Internet Creations. Unfortunately, I saw this demonstration live. I forget the gentleman's name, but Internet Creations set this up, and this was really the first time that I saw what was going to become kind of the stock IoT demo. And so you have a laptop, you have a Raspberry Pi, and I'll get back to this here in a second, and then you have some kind of smart device, or not even necessarily a smart device, just a device that's somehow connected to either the laptop or to the Raspberry Pi or possibly Arduino board, and then you have a complete loop. So in this case, in this situation, he created a case in Salesforce. That case in Salesforce would have a specific kind of priority. If it was high or above, the light that we see on the screen, on the slide here would go. So it's like a hockey style light. So like the concept was you're in a situation where you have a lot of people working cases and you want everybody in the room knowing that suddenly a high priority case was submitted and now the things is the actual light going off. And this is good, right? Like this is it's small in scale, but it is the loop. We have some kind of data coming in, we are processing it through the cloud, we're doing something meaningful that somebody can actually react to, and then we're doing something in the real world itself, like turning on a light. And this would become, for the next year, I think I probably saw 7, 8, 9, 10 demonstrations almost exactly like this, in some kind of laptop, Pi Arduino, smart appliance, and it just kind of changing out the variables, but we would always kind of go through that loop. And so when it came to 2015, I wanted to start changing things up a little bit. I'd already gone from makey keyboards, and we're getting into hockey lights and things like that. And so I went into what I called my most complicated demo ever. And what I wanted to do was show that we can truly leverage the internet. One of the things that caught me about having a laptop and a Raspberry Pi and a smart appliance is that everything's right here in front of us. And that's never the case in IoT, right? The fridge is in my dad's house. The pipeline is in Alaska. The car that we're tracking is driving all around the place. We are using the internet in order to interact with these things. So I wanted to separate the experience out a little bit. I wanted to have multiple points of integration around one use case. So instead of laptop, Pi, device, laptop, Pi, device, phone, laptop, have a lot of different touch points. Because once again, we get text messages. We talk to mobile apps. We get emails. We have Alexas. We have smart bulbs. We have these things which are becoming pervasive in our lives. And they can all kind of interact with us in different ways. So how do we break out of this concept of just one flow and one loop? And so also showcasing how IoT can satellite around our lives. And also demonstrating, because this was another difference we saw in 2015, was the consumerization of IoT was really starting to hit. So in 2014, we had shown more demos of industrial-style IoT, so robots. We had a fridge that could detect the correct inventory as well as the temperature of the fridge and things like that. By 2015, we had at the IoT zone a smart cat door. There's a smart cat door out there. And the first time I heard that we were going to demonstrate a smart cat door, I am like, who? It's kind of like the fridge, right, with the cameras. I'm like, who really needs a smart cat door? Like, how smart can a cat door be? Well, what they didn't tell me is that the smart cat door is also associated with a smart RFID chip that they put in your cat. So it's not just a smart cat door, it's a smart cat. It can do things like the cat leaves, and then you want to close the door, and then you want to wait till 5 o'clock, but let's say the cat comes back, and you want to make sure the cat eats its dinner because, oh, by the way, it's also connected to the feeder. So the cat returns, and it usually goes back out, but you want to make sure it eats its dinner before it goes back out. The door closes, waits for the feeder to go off, and then lets the cat back out. And at this point, I want to move to the suburbs and get another cat. Like, this is too much fun. Like, I can actually control my cat's behavior from the cloud, possibly better than I currently can without the cloud. So we saw this kind of actually like richer use of consumer-style devices, and we had things like, it was the first time that I ever showed Alexa live at a conference as well. And so I wanted to show that we're not just talking about Pis and sensors and things like that, but we're also talking about the kinds of things that we might find in our actual home. And so let me kind of be honest with you here and describe a little bit about what we're actually seeing here. And we're gonna start with Alexa. First thing I'm actually gonna do, so this is actually a flick. Here, we'll start with a flick. So the flick is actually a Bluetooth button It pairs with my phone. The phone makes API requests. So if I want to turn off the LifeX bulb here, and I'm also doing this to make sure my internet connection is still working. Okay, so I turn this on, it goes to the bulb, bulb goes to LifeX, LifeX turns off. Alexa, I do that all the time. Alexa is also connected to my smart devices at home. Now, Alexa comes in two different flavors, either what I call a first-party connection, which is where it's built right into the product, and you can say very natural things to her like, Alexa, turn on the study light.
Okay.
Or, as we're going to see a little bit later, we can actually also design very custom skills around Alexa so that we can have a little bit more precise control over them. Now, I showed you a little bit earlier, I do have a Raspberry Pi here, okay? This Raspberry Pi actually has all right, we'll get to that in a second. So this Raspberry Pi has almost nothing to do with the demo. I just want to call out that it's here. This is actually, what it does is the Pi 3 has a Wi-Fi, and then I added a Wi-Fi point, so this is just a Wi-Fi access point. And the bulb here doesn't like hotel-style Wi-Fi with browser logins, so this just allows me to, actually I probably shouldn't say that because I think that's violating like 3 EULAs or something like that. This allows me to have a common access point across IoT devices. Let's put it that way. Okay, so it's not actually controlling anything. It is just using a little bit of internet magic to make things a little bit easier. Now, what is controlling something is what we just saw there. So while I was talking, my phone went off. All right, well, the most reliable part of my demo is not working. So let's, maybe it doesn't like the new mirroring, I'm not sure. That's okay. What I'm gonna do is I'm going to use an audience member. I've actually always wanted to do this. I need a volunteer from the audience. So volunteer from the audience. Whoa. I just lost it. Okay. Time is it? There we go. Can you read what it says there? That's the alert notification that I just saw. Here we go. Oh, no, it's not on.
So it says, a male zombie in white dress, shirt, table decor has been detected on your desk. It may be dangerous. A Salesforce case has been created.
So a zombie has been detected on my desk, and a Salesforce case has been created. So I want to be able to easily investigate a little bit more about what's going on here. So what I'm going to do is I'm going to use our friend here, my Echo, to help get that done. However, what I want to do is be able to do that in a way that I can also kind of visualize what's going on. This is actually something that I put together as a demo for some of our internal case users. I want to be able to say, Alexa, ask Salesforce to get my latest cases.
Here are your latest cases. Case number 1. Dangerous object detected on your desk. Next case. Case number 2. Device 46,155 has exceeded threshold of 90.
Alexa.
Case number 3.
Alexa.
Issue with router speed. Next case. Case number 4.
Alexa. Open case number 1.
Open case dangerous object detected on your desk.
More information.
Here is your currently open case subject. Dangerous object detected on your desk. Priority. Medium. Status. New.
Set priority to high.
Update a case with a priority of high.
Set status to escalated.
Update a case with a status of escalated.
Chatter, prioritize next meeting.
Post it to Chatter.
I'll be very interested to see what she actually posted to Chatter. This needs to be prioritized to the next meeting. Exit. Okay, So Alexa now gives me the ability to look into my Salesforce cases, list them out, not just see what is going on, but to actually interact with them. Now, to be very clear, and I'll walk through a little bit of how this is happening a little bit more. If I did not have my browser open, the results would be the same. So the interaction with the Salesforce data is separate from the ability to track what's going on from the browser point of view. The browser point of view just allows me to be interacting with Alexa while also wandering around a room. Maybe I'm fixing a computer, maybe I'm talking to other people, and I can go back and I can see the results of those interactions in a live way. Now, what we didn't get to see because my phone was not there is, let's go to related. Unfortunately, this is a little bit clunkier on the browser. So ahead and let me save this specifically, Zombie 1, and save that. And now go back into this. And it's a little tiny. See, I was wanting to show this on my phone because it actually shows up a little bit more on my phone. Now, this is live. This is my desk back. I live on the north side of Chicago. This is actually the zombie that is actually on my desk in here in Chicago. And so what happened was when I turned on the study lights, it changed the lighting in my office, and the change in lighting itself actually detected the presence of the zombie. And I'll walk through the loop here in a second, but what I think is really important is the fact that I'm here presenting to you and there is apparently a zombie on my desk. So I would like to be able to get rid of the zombie that is on my desk. And so in order to do that, I am going to go into my feed, go home. Okay, and you can see, so now this is our Chatter. Chatter is like our enterprise Facebook/Twitter offering, allows us to have this kind of conversation with our data. You can see that not only my phone was getting updates, Chatter was getting updates as well. It gives me this description. A male zombie in white dress shirt with a table decor has been done there. I don't really care what shirt it has. I just want to say, kill that. Excuse me, I need to put my glasses on because I have no idea what I'm typing right now. Trust me, if you turn 40, you're going to know what I mean. Kill that zombie. And then just to make sure we're serious, we're going to use the hashtag really. And I'm going to hit comment and give it a second. The light has turned green. And the light has turned green. I don't know what internet I'm on. Seriously, the phone is supposed to be the most reliable part of all of this, and it's just like, doesn't even care. Okay, so I know something has changed, so the light has turned green. Let's go back to our case here in Salesforce. Let's see, there we go. Oh, my wife just texted me yay, so I think that's a success. If we go back into dangerous object, and we go back to our related information, of course there is. All of the stuff going wrong is the stuff that should be like rock solid. All the stuff that is supposed to be strange and scurious is working just fine. Yes. Let's go ahead and replace that. Now, we look to see, oh, hey, that's actually a really good picture. Because sometimes the zombie is just knocked way off screen, and so it just looks like maybe my wife just casually removed it from the camera's view, so you're not entirely sure what I just showed you was real. But you can see that the zombie has actually been dealt with. Now, I do kind of apologize because this is the really exciting part of this is the zombie getting killed, right? And you didn't get to see it. So, and I tried to get a good setup for that, and it didn't really work. And so my compromise, and I almost never do this, but my compromise to you is this. This was the first version that I actually got up and running correctly. Okay, so that's the zombie actually getting shot, actually on my desk. Slightly different setup, but the exact same flow. So, one of the things that I was trying to do here was to provide something overcomplicated to the point of believability. That there are so many moving parts to this that you have to think this is something that might actually work in the real world. And if that sounds strange to you, then you probably haven't done a lot of consulting. If you've done a lot of consulting, you've done a lot of work for other people, for other clients, you know that they don't come to you with simple, straightforward scenarios, because if they had simple, straightforward scenarios, they wouldn't have to hire you. They hire you to do the weird, complicated stuff that requires you to do object detection and change light bulbs and have voice recognition and all of this stuff in the same flow. And so one of the big goals from moving from laptop, Raspberry Pi, light, was to make things overcomplicated enough to think, I have this weird scenario. Maybe IoT can work for me. Maybe that's not so weird. Maybe it's actually a solution that we can actually put together. So what was that? What did we just see? I'll actually go back to that. That was the first version of it. The first thing that happened was Alexa controlling my lights back at home. So when I told Alexa to turn on the study lights, study is actually a group. So in LifeX, you can group bulbs. So this light bulb was in the study group, so was the light bulb that was on my desk. So when I said turn the study lights on, we saw this light go on. The desk light also itself turned on. Now, I do also want to just give a call out. LifeX is like one of the least known smart bulbs, and I love them. And I love them for two reasons. One is that each one of the smart bulbs here is actually its own Wi-Fi point. So unlike some of the smart bulbs, which rely on a hub to do all the real internet interactivity, each one of these has what's called it's actually a hardware variant of what's called an electric imp. Electric imp makes these little breadboards that basically have Wi-Fi on one side and I/O on the other side. So it's good at two things: staying on Wi-Fi and then talking to some other kind of device. So I don't need another hub or anything like this. I can actually just connect this right to the Wi-Fi, assuming it has an access point that it actually likes. They also have a great API, which allows me to either, when I was doing this trick here, where I'm calling just that, see, all the real stuff's done. So now, there we go. So we're just randomly changing the color. We can either talk to the group or we can talk directly to the light bulb. When the zombie's getting killed, that's talking directly to a light bulb, and it's just a put request to a specific point in API with a bearer token to get that done. Back at home, I've got a Raspberry Pi running Node.js, the core library that was making everything actually work. Now, this was a big goal of mine. The 2015 version of this had my wife basically pushing buttons on an Arduino to like move the demo along, kind of like faking out sensor data. And it always kind of bugged me because I'm trying to do this overcomplicated to the point of believability thing, right? Well, I want to show that we're actually detecting an actual object changing on my desk. So in this case, resemble.js takes two images and it tells you what the threshold difference is between those two images. And so all day long it's been running there, and it's been dark and it's been dark and it's been dark, and then the light goes on and it sees that it has a different image. And so it says now the image has changed to the point where now I need to figure out what is going on with this, within this image. So it's not a very smart library, but it's very good at detecting the changes between two different images. Then we post up to our platform using our REST API. That's what created the Salesforce notification. And then the second trick, I didn't want to just say something had changed. I wanted to actually be able to detail what was it that we were actually looking at. And my big goal was to be able to get the word zombie put intelligently into the demo flow somewhere. And thankfully we did. The way that the API is working here is this is an API from CamFind. CamFind actually has an iOS and Android app if you want to play around with it. They do object recognition. So you take a picture of the Alexa or a glass or the bulb or your phone, and you send it up their API, and they try to guess what is in that image. And it's actually pretty impressive. It's really good at like well-known landmarks and things like that. And it's pretty good at products. And that was one of the reasons why I went ahead and used them, because they're relatively reliable in knowing that was not just an action figure, that it was a zombie action figure actually on my desk. Now, there are different routes that you could take here. Object recognition basically just says wholesale, what am I looking at? You could also do something more along the lines of facial recognition. There's an open library called OpenCV. There's a great project out there called KittyDar. KittyDar is a Node.js application to determine if a cat is in the picture. And it does it by recognizing a cat's face. So it's trained on 10,000 different images of cats, and it knows eyes are kind of like here, and a nose is kind of like here, and a cat's mouth is kind of like here, and that picture kind of has those traits. So I think that's a cat. And I'm going to tell you that I think that a cat is in a picture. Now, those are two very different routes of trying to determine what it is that you're looking at. I started the OpenCV route, and I didn't finish it because determining what's a zombie is actually a lot harder than determining what's a cat, because we don't identify a zombie between eyes and nose and mouth. We determine a zombie because it's gray and its skin is falling off and it's missing an arm. So it's a very aesthetic quality to it that says this is actually a zombie. So I'm using ChemFind here. They actually have a great developer experience. They give you like 500 credits for free just to try things out. But just to note, there are many different ways, pun intended, to skin this particular cat. The case control using Echo, this is using our REST API. So like I said, all of the really meaningful things that we're doing up against Salesforce, those are just REST calls into our system, authenticated using OAuth, updating the case, and then it updates another record, and we have a streaming API. And so the streaming API is pushing real time down to a client. The very handy thing about this is the Pi on my desk does not have to be live on the internet. It doesn't have to have a public IP to interact with what's going in the cloud, because it's just the handshake up to the server. So as long as the client can see the server, the client can get notifications in real time from the streaming API. So as long as my Pi has internet connectivity, it can get the messages. It sent those messages to the Chrome extension. The Chrome extension itself is what was kicking off the changes that we saw within the browser. And then to kill the zombie, same basic trick, except it was looking for the chatter feed. The chatter feed with the hashtag really kicked the message over to the streaming API. The streaming API then determined what was in that message. If I use words like kill, murder, maim, shoot, aim, destroy, if it found any of those, it would then talk to the USB Dream Cheeky missile launcher that is on my desk, which is what actually shot the missile, which is what actually took out the zombie. And then finally an Apex call out over to our LifeX bulb to see those changes. And we needed luck, and I'll talk about that. How are we doing on time? About 10 minutes. Okay, I'll talk about that in a second. Because what could possibly go wrong? What? I mean, really, what? For instance, would it be possible that on a Saturday afternoon, when I'm trying to do the full end-to-end version of all of these new things moving together, would it be possible that this 64 gig card that I have on the Pi on my desk at home just melts itself? I have no idea why. I don't even know how it could possibly happen. It's just gone. No computer on this planet will even recognize its existence. All the code, all the OS, everything, gone. So little things like that, when you're setting up a demonstration like this, can kind of throw roadblocks along your way. But that's probably unlikely. What really can kind of go wrong, first of all, internet. Why did I build an entire Raspberry Pi just to duplicate a wireless access point? Because that's the kind of thing this wanted to talk to. Making sure that we have connectivity across all of these devices is the only way that we can keep all of these touch points up and running. So if the power went out at my home, boom, half this demonstration would just not be visible, right? Also, if you do start playing around with this kind of stuff, and you are going to use USB devices as opposed to a lot of Pi devices actually go through the GPIO slot. If you go through the USB devices, do note Pis have notoriously buggy USB hubs. Pi 1s, don't even go near them. Pi 2s, depends on the device you want to bring to the table. Pi 3s actually seem to have stabilized it considerably. And by buggy, what I mean is that you will get your code up and running, and especially like the webcam is taking a picture. When I tried to run this on a Pi 2, it would take a picture, and then freak out. And it would drop connectivity to the USB device, and until you restarted the entire hub, you had absolutely nothing to do. So, and there's no work, it just is, right? So that just happens. Cam find can be kind of slow. That's why there was a little bit of a pause in the middle while I did a little song of the dance in the hope that my LED bulb actually updated itself. It's also very random. It's kind of interesting because you will give it the same picture 5 times, you will get 5 different responses from it. And I kind of like that because you know it's actually thinking about what's in your picture and trying to evaluate it. And so it's not 100% deterministic. So I was very happy to see that we actually got zombie in that section. And then finally, Alexa's usually spot on, but every now and then, she just doesn't want to talk to you. And then finally, I have 2 cats at home, which I don't recommend for any kind. If you try this at home, just put the cats somewhere. They're jerks. I don't know what to tell you. However, do note that multiple points of entry like this. So I had the Alexa, I had the light bulb. I could control this demo from my phone. I could control it from my laptop. I actually had multiple routes to go. So for instance, one part failed where I couldn't show you what was on the phone, but we can kind of duck and dive a little bit. So doing something this overcomplicated actually gives you a little bit of odd level of redundancy to it, where if one part fails, you at least have enough demo on the floor to actually get things up and running. And then very, very quickly to overview the kinds of the ways that we communicate with these different devices. Alexa has a brilliant developer experience. If you can put together a web server and you can put together an endpoint that can grab a JSON and return a JSON, you can put together an Alexa skills. Amazon will take you down the route of using Lambda. I use our product Heroku, and it's actually very, very straightforward. I prefer Node because I find Node to be very fast and lightweight to build this kind of response server. But if you can put one out there, then you can start tinkering with this. And I have published none of mine, right? You can keep them all private. You can talk to your own devices. You can just tinker with it to your heart's desire. I highly recommend the Amazon experience. I also highly recommend the LifeX experience. Like I was saying, they do not require a hub, and they have a first-rate API out there. They also have not only the HTTP API, they also have a LAN API. So you can communicate from your subnetwork directly from code to the light bulb itself. I personally use this as a trick at home for party guests where I'm playing a game on the PC, and the light in the PC game is driving the lights behind me in the living room. And it's actually very low latency because it's all through the LAN, and so it's just shooting UDP packets over the network as opposed to going through the cloud. And finally, Raspberry Pi is really just Linux. If anybody's been kind of tentative about tinkering around with, Arduinos are kind of a special little style of cat, and I'll talk about that next. But if you can code Linux, or if you can Google Stack Exchange to code Linux, you can probably mess around with a Raspberry Pi. And then finally, for some of the weirder devices like the IMP that we would find in a LifeX, IMP actually also has developer boards you can get, or Arduinos. If the Arduino has an embed, it's called, which is a product by ARM, you can do the development in your browser in the cloud, and then it either delivers it right to the browser to the device, or you just plug the device in through USB and it reloads the device itself. So if like I said, the intent of today was not to teach you a bunch of stuff, but to pique your curiosity. If your curiosity is there, the other part of this message is development on this stuff has never been easier. It's never been easier to pick up this stuff and just run with it. So I'm to remind you to please remember to rate this session from the GOTO application, and do we have any questions? Okay.
Any questions? No? Thank you.
I was wondering, you mentioned how those lights don't have the hub. I wonder if you played with the Hue and how your experience was with that.
So I have not played with the Hue, not through prejudice, but just through time management. However, so I say this tentatively, but I will say that we are looking at potentially replacing a Hue demo that we were doing for one of our upcoming conferences with LifeX. I think the message with Hue is that if you are playing with it purely from a consumer point of view, setting up the lights, hooking them up through Alexa, hooking them up to your phone, it's actually probably a more seamless experience that you get from LifeX. If you're looking at it from a developer point of view, I don't think Hue is quite there yet. All righty. Thanks, everybody. Thanks for having me.